two masses are connected by a string which passes over a pulley accelerating upward at a rate a. ओके मतलब एक जो पुली है वो a एक्सेलरेशन के साथ ऊपर में अपवर्ड डायरेक्शन में मूव कर रहा है, and a1 and a2 the acceleration of bodies 1 and 2. Okay, so then the relation we have to found that small a and capital A. So at first if we rewrite this image, it will be, this is a pulley, the pulley is moves upward direction with the acceleration a. Okay, and this is for body number 1 and body number 2. So let's assume this is the ground level. So जो पुली है, let's assume that the pulley is from height h from the ground level. Okay, and the body 1 is from h1 from the ground level, and body number 2 is from h2 from the ground level. Okay, and let's assume the length of the string from this range to this range, this is x1, and from this range to this range, this is x2. Okay, and the circumference, the half circumference of the pulley, what will be this length? This length will be the half of a circle, that will be the full circle, the circumference will be 2 pi r, so the half circle will be pi r if r is the radius. Okay, so now we have to calculate to find this relation. So what is the total length of the string? So the total length of the string L will be this x1 plus of pi r and plus of this x2. Okay, this will be the total length. So it will be x1 plus pi r plus x2. Okay, so this will be the total length of the string. So if we replace the x1 and x2 with h, so what it will be? So now हम लोग करने जा रहे हैं, जो x का वैल्यू है उसको h के फॉर्म में लिखने जा रहे हैं. So what will be x1? x1 will be the total height h minus of small h1. So capital H minus of h1 will be x1 plus of pi r same रहेगा, and what will be x2? And x2 will be total height h minus of h2. So this will be x2. Okay, so हमने x को रिमूव करके h फॉर्म में the total length of string निकाल लिया. So now the L equal to the total length of the string in this form. So here the total length of the string and the circumference, half of the circumference pi r, this is constant parameter. Okay, so what is the constant parameter? This one and this one. हम लोग क्यों बोल रहे हैं? क्योंकि हम लोग अभी we have to take the help of derivative with respect to time. So अगर हम लोग टाइम के रेस्पेक्ट में बोथ साइड डेरिवेटिव करते हैं, that will be dl by dt equal to ddt of h minus of ddt of h1 plus of ddt of pi r and plus of ddt of h minus of ddt of h2. Okay, so as L is a constant figure, so derivative of a constant figure will be 0. Okay, and this will be remain same, dh by dt minus of, this is not also constant, so it will remain same, plus this also a figure is a constant, so it will be also 0, plus of dh by dt minus of dh2 by dt. Okay, so now it will be that 2 dh by dt will be equal to dh1 by dt plus of dh2 by dt. Okay, so now here we have to come to this form. Okay, so what is the dh by dt? dh by dt is nothing but the change of height in 1 second. So the change of height मतलब height में जो change हो रहा है in 1 second में, that mean after 1 second the pulley is moves to a certain height. So this will be the velocity, the change of height in per 1 second. So this part will be the two of v. What will be the v? The velocity of the pulley. So that will be the vp, velocity of the pulley, if we consider this, and dh by dt will be the velocity of block A. So block A velocity will be v1 if we consider, and block 2 velocity will be v2. So now the velocity of block A is written as mathematically v1 and velocity of block 2 is v2. So what has been asked in this question? The relation of acceleration. So again we have to derivative. So if we derivative with respect to time, it will be acceleration of the pulley a1 plus of a2, acceleration of block 2. So the relation has been come out to 2 capital A equal to a1 plus a2. So okay, so it will not be the correct answer, as because in the given question the image has been given that the acceleration of body number 2 is downwards. Okay, and body number A, the acceleration is upwards direction, and the total pulley, the direction is also upward. So here the equation have come out that everything is in positive direction, but here the block or body 2 is in negative direction. Okay, so this part will be minus of a2. So this will be 2a equal to a1 minus of a2, as because a2 is in negative direction. a1 acceleration is upward, and the capital A, the acceleration of the pulley is also upward, but the acceleration of the body 2 is downward. That's why the equation will be minus. So this will be the relation. So if we simplify this, it will be a1 minus a2 divided by 2. So option C will be correct option. So the option C will be the correct option. So hope you understand.